So looking at our work for today, today's aim says that we are going to write and graph equations of lines given a slope and a point. This is a slight departure from our work on parallel and perpendicular lines, but this is because we need this skill to do the next one with parallel and perpendicular. So taking a slight departure from that today. Half of the skill today is actually something that you can already do in a different way than we're going to look at it today. And so we're going to talk a little bit about when it comes to graphing, what's the best way to graph or choosing the best way to graph the equations. However, today our main focus is the new part, which is being able to write equations of a line given the slope and a point. Now, yesterday we were able to write equations of a line using the slope and a very specific point. What specific point did we use yesterday? Kenneth. Juan, what specific point did we use yesterday? Yeah, we used the y-intercept. So using the y-intercept is really easy because when we have y equals mx plus b, that just plugs directly in for b. No big deal. However, we actually are not given an intercept today. We are given just a random point that is on the line. How do I know this point is not the y-intercept? What should signify to me as I look at this point right here on this problem that it is not the y-intercept? Jose, how do I know this is not the y-intercept? Yeah, because the x value is not 0. So, we do have part of the y equals mx plus b. Which part do we already have? Which part did I give to you? The slope. So let's go ahead and put that in. Y equals 3/5 x plus b. Now, we don't have the b, right? Because that's not the y-intercept. We're not given a y-intercept here. We are given a point, though, and that point contains some very important information that we can use with this equation. What does that point contain? What makes up that point? Rebecca? A y and an x. So we're given an x and a y that we know are supposed to make this equation true. We know these two numbers should make this equation true. So if we plug those numbers in, 3 is equal to 3/5 times -5/1. We know this is going to continue to make this equation true. And now we have an equation with one variable. Well, we know what to do with that, right? Solve it. And if we solve this, we're going to be solving for b, which means we can complete this equation up here because we'll know b. All right, so I'm going to start by going ahead and doing this multiplication. And I'm going to cancel out the 5s. It's a bad date, so that's going to give me a -3 plus b. And simple one step to solve this equation. What's the one step that I need to solve this equation? What do I need to do to use this equation to find out what my y-intercept is? Malcolm? Yeah, add a +3 to both sides. So our y-intercept is 6. And now we can plug that into our equation that we had almost everything that we needed. We were just missing that b. Y equals 3/5 x plus 6. Now we can graph it. Y-intercept of 6. Rise 3, run 5. I'm out of space here to rise 3, so I'm going to do the opposite direction, which means rise -3 and go backwards 5. Still keeps me on my line, as I can see here. And then I'm going to take my straight edge. How did I just do that? I didn't draw that line. No, I didn't. I definitely did not. I didn't have a straight edge. I didn't do it. It wasn't me. I mean, I do have mad skills. Let's not get mistaken here. All right. Make me sad. All right, and that's it. All right, next one. It says write the equation of a line given the following slope and intercept. Now again, it says intercept. How do I know this is actually not an intercept? Well, how do I know this is not an intercept? Right, it doesn't have 0 for x or for y. So there are two numbers here. There's an x and a y value. This is not a y-intercept. So that means that we're going to have to use this idea that we just came up with. We've got negative 2x plus we don't know the b. But we do have the point, and the point contains an x and a y. So I've got my x, I've got my x, and I've got my y. And so that's going to be 6 plugged in for y. Negative 2 is going to be times 3 is my x plus b. Simple equation solving here. Going to go ahead and simplify this first by multiplying. I get 6 is equal to negative 6 plus b. And Marlon, what do I need to do to solve this for my y-intercept? Add what? Add positive 6 to both sides. Now I can complete my equation up here. Y is equal to negative 2x plus 12. And I'm now ready to do the second part, which says to graph both lines. There's only one line here, Mr. Boots. Graph the line below. All right. What seems to be the problem with graphing this line below? Rebecca? Yeah, if we're looking at the y-intercept, we can't fit that on the coordinate grid that's given to us. Now here's a secret. This is what I was telling you before, that you already knew how to graph this. If I had just kind of said, hey, you know what? Oh, not what I want. If I had just said, oh man, fail. Okay, here we go. I got this. There we go. If I had just given you this information and I said, graph it, could you have graphed it?
Yes.
Yeah, what would you have done? If I had just given you this information, I had just said graph it, even before we started talking today, what would you have done, Javier?
I would go straight to the middle and look up the point 336, and then I'll do the slope going out 2, and to the right one.
So he's telling me to go to the point 3,6 and follow the slope negative 2, 1, negative 2, 1, following the slope. And sure enough, once I get my straight edge involved here, it looks like we can pretty much estimate that if I graph this correctly, that if we had extended this up a little bit, this probably looks like this would have hit right about at positive 12. So that looks good. So the great thing about this is we can choose which method we really want to graph it when it comes to graphing it, but we need to know the skill of being able to write the equation. That's the real skill that we're learning today, being able to write the equation. Because we had another way that we could have graphed this. All right, last problem. Once again, we are given a slope and a point, not an intercept. I know this is not an intercept because it doesn't have 0 for x or y. So we're going to plug in y equals mx plus b. We know the m is the slope, negative 2/3, plus b. And I've got my point I can plug in is negative 6 goes to negative 2/3 times my x, which is 4, plus b. Now as I do the multiplication, I'm going to get negative 6 is equal to negative 8 over 3. Oh, no, not x. X is gone. We replaced it. Plus b. And so what do I need to do to solve for b here? Solve for my y-intercept. Katie, what do I need to do to solve for my y-intercept here? Katie? Yeah, positive 8/3 to both sides. So this is just a little bit more messy because we have fractions interacting with whole numbers. But we know how to deal with this. We dealt with this earlier in this unit. And so I have 8/3 plus negative 6 over 1. Now, if I want to add these, what do I have to do? Adriana? Get a common denominator, which is going to be 3. So that's going to give me, multiplying by 3 over 3 gives me negative 18 over 3. Fernando, like signs add or opposite signs subtract? Opposite sign subtract, so I'm going to get 10 over 3 is equal to b. Rebecca's got it. Rebecca's raising her hand. Why aren't you all? What's wrong here? The most common mistake throughout seventh grade has just happened. Graciela. It's a negative, a sign error. The most common mistake in 7th grade math, a sign error. We did not take the sign of the larger number. Oops. B is equal to negative 10/3, so we can finish writing our equation. Y is equal to negative 2/3 x plus we now know our b is negative 10/3. Now, we definitely can go about graphing this using the equation. This is a skill that you should have because we did do this and it was quizzed earlier in this unit. Negative 10/3 is the same thing as negative 3.33. So I'm going to come down to negative 3 1/3. I'm just going to approximate where that is between negative 3 and negative 4. I'm going to rise negative 2 and run 3. I'm going to rise negative 2 and run 3. This is one way I could have graphed a line. What's the other way that might have actually been better and easier for this line? What's the other way we could have graphed this that might have been better and easier? Katie? Yeah, using the point. So the point that we're given is -4, or excuse me, 4, -6 over 4 down to -6. Rise -2, run 3. Rise -2, run 3. And sure enough, it should look like all these points are on the same line. And they are. So this really kind of checks that we did get those first points in the right place. And I'm going to take my straight edge. And it does appear to go through all points. Now, why is it that I would say that graphing it the second way would be better? Graphing it the way that we used to, not using the equation. Why would I say that's better? And I don't want to hear because it's easier. Why is it better? Manuel.
So you don't deal with fractions or decimals. You don't have to go off the chart.
So you don't have to deal with fractions or decimals, get off the chart. Is there anybody who wants to sharpen that up a little bit more about why that would be better? Because he's definitely, I think he's got the right idea. He's just not explaining it quite as sharply as I would want. Adriana? It's more accurate. That's exactly what I would want to hear. Okay, that's what Javier was going to say too. You guys, great minds think alike. All right? So it's more accurate because it's going clearly through. When we did those other points, we estimated where that was. And so this is kind of an estimate of where that is. It's pretty close. It's obviously pretty close because we drew the line and it went through the points. But that being said, it's more accurate. All right, let's look at our key points for today really quickly. Thinking about our key points being really moving forward towards being able to write equations given a slope and a point. Big picture, writing equations, slope and a point. Key points for today. Raised hands now. Please, please. Javier, we'll give you a chance since we didn't let you tell me how accurate things were. How did we start finding these equations? How do I start writing my equation, Rebecca?
Plug the slope and the coordinate points into the
Yep.
line.
Plug the slope and point, and I'm going to put in parentheses here just as a reminder. The point is our x and our y. Plug that into, and also next to slope I'm going to put m. Y equals mx plus b. And I'm putting a 2 here because I want you to finish this sentence with what's the reason why we're doing that. Plug the slope and point into y equals mx plus b to do what? What's the purpose? What are we trying to do, Michael? Find the y-intercept. To find the y-intercept. And I'm going to put in parentheses b. Once we've got that key point, write the equation with m and b. M and B plugged in. That's it. That's our key points for today. You already knew how to graph this. You knew a method to graph this. The graphing is the easy part. Okay? Questions about our work for today?